Hey guys, Nox Lupus back here with another Redstone video. As you can see, I have 3 boards. Mainly, these are 3 things that you'll need to know for Redstone. I have most of them up here. A few things are a little more complicated than that, but for the main part, these are them. We're not going to go through these 2 today, just this one. But I do need to explain what these are so you can understand that one. So first of all, we have the input. Input is anything that puts signal into the wire. Now, like I said, this can be a little more complicated than that. Some of these might fall to more than one category, but this is what I went with. The lever is the simplest input, pretty much. It's just like a light switch in your house, so you can turn it on and off. Very simple. These are outputs. When you put redstone, because just like how I said it's a switch, it's like wire, and when you put the wire into these, they give an output. The very simplest of that, at least for this again, is the redstone lamp. It has 2 states, on, off. Very simple. So those are the 2 that we'll be using today. For this part, I'm going to be going over the redstone dust. Again, the simplest of them all. This comes in, you can find it trading, you can find it in some jungle temples, there's a trap in there, as well as you can get it from redstone ore and occasionally from chests. So all these blocks you cannot put redstone on. Pretty much the rule is, as long as it's see-through or glass, more or less, you cannot put redstone on it. More or less, that's the rule. So these are the different setups that I have here for redstone. So I'm going to get rid of these. First, we'll go through the simplest. This is a redstone piece. I can turn it on, and it turns to a brighter color and has these little particles. I can turn it off. The same thing over here. This one is split into a cross, so you can see the different parts. You can have a dot like that. You can have a line, or you can have it turning. And you also can have it turn in just an L, or in a T, or in a cross. So you can see just like that. Again, it turns on. You do notice a little bit of a color. This color is a little darker, but I'll explain that later. So then we have this. It just snakes around. You can see how the redstone turns. Different texture packs will have it set up differently, obviously, but that's the normal texture pack. So if I turn this on, you can see that this one is on, but this one is not. You also can see that this is very dark, and this one is normal colored. So after 15 blocks, so that means this is the 16th block, it will die out. So it will only reach 15 blocks. Here it is at 15 blocks, and it is powering this light. But here it is at 16 blocks, and is not powering this light. So keep that in mind. There is a way for this at this point. That is the limit of our redstone knowledge. 15 blocks and you're done. You can notice that the coloration, I'll walk over it real quick, as it dies down. Just like that. Pretty simple. Turn this one off. Then we have this one. So first, I'll stand over here. Just look at this side. If I turn this on, the redstone will jump up here. You can't actually hit this. It has no hitbox. It just adds that. So the hitboxes are always on the top of a surface. And that goes up to there, just like you would expect. If there is a solid block in the way, then it cuts this wire off. And you can see that this is turned back into a blob and is no longer empowering this. If I break that, it will power it. As well as, again, the rule is pretty much if it's opaque, you can see through it, then it'll do this, more or less. If I put a block on top of it, this particular block, it will still go over. So with glass, you can not put redstone on top of that. But you can see over here, with glowstone, you can put redstone on top, and it still lets it go through. Although it does make the circle, the current still goes through. See, that does not happen with a solid block. Turn this off. This is the last thing. It's a little more advanced, but because it is just redstone, I'm going to show it to you guys. Just like that, when you turn it on, the redstone turns this lamp on. It goes up and also turns this lamp on. Pretty simple. But if you were to turn it on this side, this is when it does something a little crazy. The redstone power does not go downwards. So you can use this to make sure that your input is on the right side. Normally goes one direction, only goes that way. And then the last thing, this is pretty cool, in particular if you're trying to go upwards. You can go upwards as far as 15 blocks before you run out of signal in a 2 by 1 gap. So you can see if I turn this on, it takes the power from down here. You can see it turned on the lamp and turns on this lamp. It goes up. I can turn this off. But you can see this lamp is powered, so there's power here. It does not go downwards, so it only works for going up. That is redstone dust. The next thing will be a redstone repeater. Okay, so now we are on to the redstone repeater. The redstone repeater is a wire, just like redstone dust. Again, can't be placed on these kinds of blocks. I've chosen dark oak for the block under the redstone repeater. The crafting recipe is here. You have 2 torches, redstone dust, and stone blocks on the bottom. No, it has to be stone blocks. It cannot be cobblestone or stone bricks or any other thing like that. So, first, the appearance of the redstone repeater. You can see it has 2 torches, kind of like it does in the recipe, and a bottom. I'll explain what that means, but note that the torch does move when I click on it. You also can kind of notice an arrow, if you look pretty abstractly, facing that direction. That will come into play later. That's the on position. Again, it kind of lights up and it gives off some particles. Note that I had to put the redstone, the power source, behind it. It does not work if I put it down low, because it needs the power from behind, whereas redstone just needs it from the bottom. So, we'll do this next. As you can see, you can move it. I showed you that, and these are the 4 states that can be in. For each time you move it back 1, you add an extra tick. So it starts at 1 tick, then 2 ticks. Even though it's back only 1, it's still 2 because originally it's at 1 tick. Then 3, then 4. A tick is 0.05 of a second. There's 20 ticks in a second. If I'm wrong there'll be an annotation. So that can be used as a delay. And real quick, I'll show that. So you can see I have 2 lamps here. One has redstone and one has repeaters. These repeaters are on a 4 tick delay. So if I go over here and I pull the lever, that one's on, and you can see the redstone is going slower and it eventually turns that one on. So there's one use for them. It's a delay. Now it is off. I show this. So there's 3 things happening here when I pull that lever. One, this lever is powering this block, so it's also powering this block. I haven't explained that yet, so I'm sorry I kind of jumped ahead there. I didn't think about that. But this block being powered, the repeater can take power from that and go to this torch, as well as the repeater can take power from that block and go to, sorry, not a torch, it's a lamp, go to this lamp, and the repeater can take power from that lever and go to this lamp. So when I pull it, notice that one turns on and that one turns on, but this one is not. If we look at the repeater, you can see the arrow is pointing that direction, where the arrow in this one is pointing towards the lamp. The arrow is not pointing towards the lamp in this situation. This is demonstrating that the repeater, just like the glowstone over there, can only go one direction. A repeater cannot go backwards. It's a good way to make sure that you don't add extra signal to an original signal, but we won't go over that right now. So it's a little weird, but it's extremely useful, and it's pretty simple once you get the hang of it. It can be annoying to set up, but just remember, until you get the hang of like how it looks, there is an arrow kind of set out like that. So the other main use that the repeater has is, I believe it's called a diode. No, it's not called a diode. I think it's just a repeater. But you can see this is the 15th block. So this is the 16th block, and this is the 17th block. So it's not powering this, even though it's being powered down here. Turn off and on. So what the repeater does is it can take the signal from this and it can repeat it to the full strength, and now it turns this on. So now this signal can go on for 15 more blocks before it dies out. That is the other main use of the repeater. Just like that. Notice it will take a tick for it to go through because it does slow it down. So if you're making a machine and you have more, you have things really closely timed, take that into account. The lesser known, see, we'll do this one first. This is pretty simple. It has to do with that. The repeater can take power from this block. So you can see here, RedStone won't travel to there. But if we put a repeater here, it pushes the power into this block, and it comes out over here to the lamp. We also, if we keep that as RedStone, we can put the repeater here. I'm going to get rid of that. And it can take the power from this block and put it into a lamp. So then this is probably the least used thing for it, but it kind of works like a bit system, a 0 or a 1, because RedStone can be on or off. It actually has 15 different states, but until we get to the comparator, that doesn't really mean anything. First of all, note this signal will not turn on that lamp. And note this bar, if we use RedStone, it will not do that. So turn that off. If we turn this on, it would turns on this light just like you would expect. Turn it off, turns off that light just like you would expect. But if we put this on, it locks the repeater. So now we can do anything with this lever. We can put any signal into this repeater and nothing will change with the light. And you can see when I unlocked it, the signal went through. Now if I lock it while the signal's in there, I can turn this off. I can even get rid of it, and the signal will still be there. That's useful for memory, and just overall some computer stuff. So that is the repeater, and now we will be dealing with the RedStone comparator. So now we're on to comparators. Before we do that, there is a quick thing that I need to show you. If you press F3 or the equivalent on your computer, when you look at something, it will show what it is. So right now, it's over here. We want to look at this power number right under north side. So that power number is 0 at the moment because this is off. But if I turn it on, you can see it's 15, 14, 13, 12, and so on as you go down the line until eventually it gets to 0. That way you can tell what level the power is at, and that will be more important in comparators. So I want you to understand that that is how that level system works. So, start off, this is the crafting recipe. Pretty simple. Quartz you have to get in Nether if you didn't know, but everything else is pretty standard. This is the general look of the comparator. That's it on and off. You can see a little red in there lights up. As well as you can see this back torch. If I right click on it, it turns on and off. Pretty simple. That comes into play later, but we don't need to know that right now. So I want to pull this chest down. This one demonstrates the same thing. It's just showing that you can put a block behind the chest and it'll still work. So this is this is a chest and it has some items in it, and this sees how many items are in the inventory, what percentage of the inventory is full, and puts out a strength level accordingly. Now I only have 2 pistons here, but this could go out the full 15 length. So if I take some of this out, you can see one of these goes down. If I take it all out, see both go down. Now if I replace it with this chest that has it full, you can see that it's a much brighter color, and that's because it's a much stronger signal versus this color, which is with only about 2 stacks in it. Just stick those in there for now. Stick this one in there. So that's that. People use that for traps. If you try to steal their stuff, they can tell and do that kind of stuff. But that's for different videos. So this is what. So actually, I want to do this one next. So as I've explained before, power has redstone signal has a strength of 15. It can go to 15 blocks and then it dies out. So as you can see, it does not reach this lamp. Now, for the repeater, as I've again already shown, if you turn this on, it repeats the signal, bring it up to its full 15 strength, and then going again. For a comparator, if we stick it here, it doesn't repeat it, but it takes this signal, so we can see it's a signal number 1, and it puts over here, signal number 1. And we can keep doing that, and now that's a signal number 1, it gets over there. So a comparator keeps the same strength of signal. So it used to be, before we knew about comparators, you had a binary system. You only had on and off. But now with comparators, you can do some stuff. She'll have 15 different levels and then off. Different inputs, different levels, different amounts of information you can put into this redstone thing. So it's quite a big help. So it is important to understand. So if you are, I know I am guilty of this, if you are watching this while doing something else, now is a good time to start listening and watching, because this is where it gets a little complicated. So people have named the inputs to this comparator. There are 3. There is C, there is B, and there is A. So it's pretty simple. C is the back input, B is the side input, and A is I'm looking at that the wrong way, sorry. I had this flipped around. A is the back input, and C is the out input, and B is the side input. So really you would be looking at it like this, the redstone signal going that way. So, keeping that in mind, this is where it gets complicated. So I can turn that off. I have this board here, but that comes in later. So you can see I have green and yellow. Yellow is a signal strength of 14, where green is a signal strength of 12. Keep that in mind. Oops. So, when it is in this mode, it is in, you can see it actually says over here, comparator mode. And it compares the 2 signals. So if I put green on, then it checks this side is a power of 0, and this side is a power of 12. And because 0 is smaller than 12, it compares it and says everything's good. So it sends it through. Now, if they're the same, this is again 12 and this is 12, it compares and says it's the same. So it says it's good and sends everything through. But if we change it so that it is at a power level of 14, now it is greater than 12, and when it compares it says the side input is greater than the back input, so it puts out no input. One sec. Redstone is remarkable. Turns out day. So that's what that does. So you can compare 2 signals and see if one is stronger or not. That's pretty simple. Then this is the harder of the 2 to understand. If I put it up, now you can see it's in subtraction mode, comparator mode, subtraction mode. What this does is it takes signal, what would that be, B, and subtracts it from signal A to get signal C. I think I did that right. Yep. So that's what this board is for. So yellow, as I already showed you, you see this is on yellow, right? Nope, it's on green. This is on yellow. So that is a power of 14, and that's a power of 12. You see that 14 and 12. So in this board, we have 14 and we take 12 from it and we get 2. And here we have 14, we take 14, we get 0. Here we have 12 and we have 12 and we get 0. And here we have, this is a little interesting, we have 14 and 12 and we get -2. But in Minecraft you don't have negative signals, so we can call that equal to 0. If I had a squiggly equal, I would use that, but I do not on my keyboard. So we can use this board to help us, just to help us remember what the numbers are. So if I take, according to this board, turn everything off. If I take 14 and 14, we get an output of 0. So I'll put in 14 and 14, and that is true. It subtracts 14 from 14, and you get 0. Same thing with 12 and 12. It takes 12 from 12, and it gets 0. We also have 14 and 12. So if we take we take 12 from 14. Oops. Then you get 0, because it's actually -2, but because there's no such thing as negative in the power, it just gives you 0. Put these all up. So then the last one, this is when it gets interesting. If we have 12 and we take 14 from it, we get 2. And you can see this signal strength of 2 is being output, therefore 2 are up. So you can do some pretty cool stuff with that. That's for later videos. One thing to note is that it does have a delay. These repeaters are set on a delay of 1. You can see they're equal to the comparators, slower than the RedStone signal. But I mean, I don't think that does anything. Yep, it doesn't do anything. So they don't slow anything down. So I wanted to redo that because I messed something up. This is a comparator clock. It's not something that I really should be teaching you, but I felt like it should be in the video about comparators if you're somebody just wanting to learn about comparators themselves versus taking the whole RedStone series. So I'm just going to show you the layout. I'm not going to explain how it works now because it's a little complicated. That'll be for later videos that I make on clocks, but that's just the setup. Comparator clock, I believe it's the fastest clock as far as I know. Like I said, I'm not going to go over how that works. That's just the setup. I thought it should be shown in this video on comparators, since it is a big part of what comparators are used for in the day-to-day Minecraft building. Notice it does have to be in subtraction mode. So that has been comparators. Got all that right? Yep. So we just did the wires, RedStone, repeaters, and comparators. Like I said, some things double as more than one thing, but that's why I've chosen as these. So we may go back and discuss more wire stuff, but right now we're done with that. I believe the next one I'll do is outputs. Then we have inputs. Outputs are pretty simple. Hope to see you then. Bye.